Welcome, math friends. Thanks for joining. We're going to be talking about quadratic functions today. We're going to discuss their domain, range, what a simple sketch looks like for the parent function, how you would transform it, whether there are asymptotes. Let's get started. A quadratic function is a polynomial that has a highest degree of 2. Standard form of a quadratic function is y equals ax squared plus bx plus c. In order to evaluate a quadratic function, you substitute in values for the x, and you get out the output of y. And always follow the order of operations. For instance, if I said y equals x squared plus 2x minus 3, and I wanted you to evaluate for x equals -1, I would substitute in -1 squared plus 2 times -1 minus 3. I'm going to exponent first. -1 times -1 is +1. Make sure you use parentheses on your calculator. If you don't, you'll get a negative out, and a negative squared is never negative. 2 times -1 is -2 minus 3. 1 minus 2 is -1. -1 minus 3 is -4. That means for this equation, at x equals -1, the function value is -4. Domain, remember, refers to the set of all x values for the function. For x values that we're substituting into a quadratic, negatives work because negatives squared are positives. Positives work because positive squares are positive. I'm not having to do some sort of evaluation that might take a square root of a negative or any of that. So I can square any positive number, I can square any negative number and get an output, which means that the domain is all real numbers. And remember, how you write your domain is up to what your teacher would like. You could say all real numbers using the symbol. You could write it in interval notation from -infinity to infinity. You could write it in set notation, where you're talking about the set of x such that x goes from -infinity to +infinity. Just remember that infinity and -infinity are not actual values, and so you don't want to use brackets or less than or equal to symbols because it's getting larger and larger without bound. You can always get bigger. The range of the function, I'm going to talk about the parent function here. If you transform it, your range will change. The range of your function, if you have a quadratic and you are taking some number and squaring it, that's always going to be positive. So this is for the parent function. Any positive number squared is going to be positive. Any negative number squared is going to be positive. So I've got the positives handled, I've got the negatives handled. What about 0? 0 squared is 0. This means that the lowest number that I could get for the function output is 0. It's going to be 0 or more. That means that the range is from 0 up to positive infinity. Okay. If I was to write that in set notation, I would say the set of all y values such that y goes from 0 or more. Now, if I was to translate this function or reflect it, that is going to change your range. You need to be familiar with transformations and how that adjusts your function. Essentially, your parabola of your quadratic function is going to have either a maximum or a minimum, and then it's going to go all the way down or all the way up. Unless you turn it into a piecewise, that's a whole different situation. But if it has a minimum value, it's going to go from that minimum value all the way to infinity. If it has a maximum value, it's going to go from that maximum value down to -infinity. So if you have a positive function, let's say your a value is positive, go to the transformation video to learn about what happens with your leading coefficient. So if there is a maximum, your graph is going to go from that maximum value to -infinity. And we would write that as -infinity up to that max value. If there is a minimum, that's your starting point. And that goes all the way up to positive infinity. Your range will adjust depending on how you transform your function. I'm going to sketch the standard parent function that can help you with your transformations. The parabola goes through some very specific points because you're taking a number and squaring it. So you know 1 squared is 1, 2 squared is 4, 3 squared is 9. And so we can use that to sketch our main parent function. It's always important to graph, I would say, at least 5 points on your parabola to get an accurate sketch. You can make 2 points into a line. A parabola is not a line, it's a curve. You can do 3, but it's better to get an idea of whether you have a stretch or a compression by doing at least 5 points. I'm going to then take the points -2, -1, 0, 1, and 2, and use my table here. F of -2 is going to take -2 and square it. Again, -2 times -2 is +4, which gives me the point -2, 4. F of -1 is -1 squared. -1 times -1 is +1. That means I have the point -1, +1. F of 0 is equal to 0 squared. 0 times 0 is 0. I then have the point 0, 0, which means my parent function goes through the origin. F of 1 is equal to 1 squared. 1 squared is 1 times 1, which is 1. I have the point 1, 1. F of 2 is equal to 2 squared, which means 2 times 2, which is 4. And I have the point 2, 4. Notice that for both my positive and my -2, I had the output of 4. For my positive and -1, I had the output of 1. This is an even function. It is symmetric about the y-axis. So wherever your line of symmetry is, your graph is going to be symmetric. So whatever you do from the vertex on one side, you need to do the same on the other side. Graphing this parabola, the point, it goes through the origin 0, 0. From the origin, I use this to sketch. If I have a standard parabola that is not stretched or compressed, I can take my vertex anywhere it is, shifted right, left, up, or down, and go over 1, up 1. And I can go over 2, up 4. That's true if I've shifted it right or left, shifted it up or down. If I have stretched or compressed it, it's going to adjust those points. It doesn't work. And then I mirror it on the other side. Left 1, up 1, left 2, up 4. And that helps me very quickly graph my parabola. Notice that is through the points 1, 1, 2, 4, -1, +1, -2, +4. And then my graph, I actually have enough to do 3. 1, 2, 3 squared is 9. So I'm going to go up to 9 and make another point and mirror that on the other side. My axis of symmetry here is right down the middle. So if I folded it at that axis of symmetry, the left side and the right side point should line up. And I'm going to make a curve. This is the standard parabola. I can then transform this. I can shift it right, left, up, down, reflect, stretch, or compress vertically and horizontally. And we'll talk about that in a second. But what I want you to notice is I mentioned the axis of symmetry. You can calculate the axis of symmetry by taking x equal to opposite of the b value over 2 times a. If I take the negative b over 2 times a leading coefficient, that's going to give me that x value of where my axis of symmetry is. For my parent function here, a was 1 and b was 0, and c was also 0. That means I would take -0 over 2 times 1, which is 0 over 2. X equals 0 was then my axis of symmetry. I can also find my vertex this way. My vertex is that first x equals, and then the function at that value. The vertex is found by taking -b over 2a for the x and the function at -b over 2a for the y. That means I take the 0, plug it into the function, and see what y is. Y at x equals 0 was 0. That means that my vertex was 0, 0. That matches. Let's go back to the previous example I had with x squared plus 2x minus 3. Identifying A, B, and C. A is 1. It's implied to be 1 since there is no number in front of the x squared. B is 2, and C is -3. The axis of symmetry would be opposite B over 2 times A. -2 over 2 is -1. Then the vertex is going to be -1 and what the function is at -1. That means I need to plug in -1 and get the vertex. I've already done that. I plugged in -1 earlier and I got -4. If I wanted to graph this function, I would go to -1, -4, and then since A is 1, I could go over 1, up 1, over 2, up 4. I'm a little bit off the graph here, but it would start here, go over 1, up 1, over 1. I could go over 2, up 4, and I could make my parabola. Are there any asymptotes? Are there any values that your graph is approaching but never touches? It takes on the minimum and the maximum value, so it's going to take on that lowest value. And then in terms of x, I can plug in any x. All real numbers work. So there are no asymptotes in a quadratic function. Transforming a parabola, I encourage you to watch the transformation video. We have our parent function that is now adjusted by a, b, h, and k. You will typically see transformations where the b is not included, but it could be that the b is squared on the inside, and that is going to horizontally stretch or compress. A is going to vertically stretch, compress, or reflect. B is going to horizontally stretch, reflect, or compress. H is going to shift right or left, and K is going to shift up or down. Hope this was helpful. Thank you for watching.